Hey everyone, and welcome to this explainer. Today we are diving headfirst into Iain McGilchrist's absolutely paradigm-shifting thesis on the divided brain, straight from his phenomenal book, The Master and His Emissary. We're going to completely rewire how you think about the architecture of your own mind. We're not just talking basic neuroscience here. We're exploring how the literal structure of our brains has shaped human history and the very world we live in today. It's a fascinating ride, so let's get into it. Now, I want you to really think about this for a second. The brain is the ultimate organ of connection, right? Its entire purpose, as we generally understand it, is to make endless millions of connections. So why on earth is it so clearly, so profoundly divided straight down the middle? I mean, evolution had millions of years, and it could have easily favored a unified, singular supercomputer brain, which honestly seems like it would offer massive advantages. Yet, as we'll see, that division is there for a very specific, totally fascinating reason. Okay, let's jump right into Section 1, the pop culture brain myth. Before we get to the real neuroscience, we've got to bust a massive, deeply entrenched myth that has plagued this topic for literally decades. You know the one. We've all heard these pop culture tropes in management seminars or, those quirky personality quizzes. The myth goes basically like this. The left hemisphere is gritty, rational, logical, and somehow male. And the right hemisphere, well, that one's airy-fairy, sensitive, highly creative, and somehow female. It's essentially this idea that the left brain is a boring accountant, and the right brain is a dreamy artist. Well, let me be absolutely clear here. That is entirely wrong. Literally throw that out the window. Both hemispheres are crucially involved in reason, just as they are both heavily involved in language. And yes, both play a massive part in creativity. The idea that functions are just neatly boxed into one side or the other is a complete travesty of actual neuroscience. So the crucial takeaway here is this. The difference between the hemispheres isn't in what they do. Basically, everything goes on in both. The real profound difference lies in how they do it. Which brings us to Section 2, why divide the brain? If both sides are basically doing the same tasks, why do we have this grand anatomical mystery where our neural hardware is physically split? It's wild. Even incredibly early in embryological development, we're talking at about 5 weeks gestation, the brain naturally starts separating into two distinct halves out of a single midline structure. And rather than fusing together as development goes on, the way our skull bones eventually fuse, the brain actually goes out of its way to actively maintain and enhance this physical separation. When you look at the brain from above, that physical rift is obvious, but pay attention to the base of that divide. Down there, you have a massive band of neural tissue connecting the two halves, called the corpus callosum. Now, for the longest time, scientists honestly thought this was just a structural bolster, like a physical support beam to stop the brain from sagging. But now, we know it contains up to 800 million nerve fibers connecting the two sides. Now, you'd naturally assume, oh, those millions of fibers are just constantly chatting, sharing information, right? Nope. The evidence actually shows that the primary effect of this transmission is functional inhibition. Basically, a huge purpose of the corpus callosum is to act as a neural brake, stopping the other hemisphere from interfering. This brilliantly suggests that the two sides have distinct, opposing ways of operating, and they quite literally need to be kept apart so they don't step on each other's toes. So why the need for a brake? Let's explore that in Section 3, 2 modes of attention. To understand why the brain needs to inhibit itself, we have to look at our competing needs for attention. Picture a bird out in the wild. It faces a terrible life or death conundrum every single day. It needs to eat, which requires incredibly narrow, laser-focused precision on a single tiny seed against a background of grit. But if it only focuses on the seed, it's going to get eaten by a predator. So it simultaneously needs broad, open, vigilant attention to its entire environment. How does it solve this? By using different strategies with either eye. It uses its right eye, which feeds to the left hemisphere, for the narrow focus of feeding. And it uses the left eye, feeding the right hemisphere, to scan for danger. It's an elegant solution. And when you connect this animal behavior directly to human cognition, a massive light bulb goes off. The left hemisphere is built for narrow, manipulative focus. It isolates things from their context so we can use them, grasp them, and control them. The right hemisphere, on the flip side, gives us broad, open, receptive attention. It sees the wider context, how we relate to others, and the big picture. We absolutely need both to survive, but they are completely incompatible modes of attention. You just can't hold them both at the exact same moment. Moving right along to Section 4, Anatomy of an Asymmetrical Brain. So how does this actually play out inside the human skull? The physical reality of this split in us is truly mind-blowing. Just look at the sheer scale of the human frontal lobes, which is the most recently evolved part of our neocortex. The defining features of what makes us human can be traced right to this area. These frontal lobes give us the incredible ability to stand back from the immediate push and pull of the moment. They let us plan, think flexibly, and genuinely take control of our environment. To really put that into perspective, in humans, the frontal lobes take up an astonishing 35% of total brain volume. Compare that to just 7% in a highly intelligent animal like a dog, or about 17% in lesser apes. That's a massive leap. And within this huge expansion, there's actually more heavily insulated white matter in the human right hemisphere than in the left, which allows for incredibly fast, highly complex interconnections. This physical expansion grants us what McGilchrist calls necessary distance. But here's the catch. This distance does two completely opposing things. On the left hemisphere side, this distance creates detachment. It makes us these Machiavellian exploiters, calculating exactly how to manipulate the world and outwit our opponents. But simultaneously, over on the right hemisphere side, that exact same distance allows us to step back and be deeply social Erasmian creatures. It's what allows us to truly empathize with others, recognizing them as feeling beings just like ourselves. Which leads us to the ultimate physical manifestation of this tension, the Yakovlevian torque. This is so cool. The brain isn't just divided, it is literally physically twisted. It's pushed wider on the right side towards the front and wider on the left side towards the back. It's honestly as if someone grabbed the brain from below and gave it a sharp clockwise tweak. Since biological structure is an expression of function, this twisting implies the left and right hemispheres are literally expanding in different areas to accommodate two entirely different ways of being in the world. All right, bringing it all together in Section 5, the master and his emissary. This is where the biology hits a philosophical climax, tying the literal structure of our neural pathways directly to the human condition. McGilchrist introduces this powerful parable from Friedrich Nietzsche. It goes like this. There was once a wise, holistic master who ruled a very prosperous domain. But as the kingdom grew, the master realized he couldn't micromanage every little thing. He needed to maintain his broad, big-picture view. So he trained a clever, hyper-focused emissary to travel around and handle the granular, day-to-day details. In our brains, the right hemisphere is that wise master, seeing the broad, connected context of reality. And the left hemisphere, that's the emissary, sent out to narrowly focus, grasp, and manipulate the specifics. But of course, the story has a tragic flaw. Because the emissary's vision is so incredibly narrow, he simply doesn't understand the master's broad wisdom. As the quote goes, the emissary became contemptuous of his master. The master was usurped, the people were duped, the domain became a tyranny. The narrow-minded emissary basically starts to believe his limited, fragmented view of the world is the only view. He overthrows the wise master, and the whole system collapses in ruins. So as we wrap up this explainer, I want to leave you with a highly provocative question. Has the emissary betrayed the master in our modern world? Are we currently living in a society where the left hemisphere's mechanistic, fragmented, decontextualized way of viewing things has completely taken over? If our brains literally construct our reality, then understanding this profound neural division might be the absolute key to understanding the trajectory of Western civilization itself. Think about that the next time you're trying to solve a tough problem. Which hemisphere is really running the show up there? Thank you so much for joining me on this deep dive, and as always, keep questioning the world around you.